Hello everyone, welcome to my new lecture series. This is Vignesh, working as an assistant professor in SNS College of Engineering. And in this lecture series, we are talking about the heat transfer and its modes of heat transfer. So, in my previous videos, we have seen about the conduction, how the heat is transferred in the solid mediums, and convection, how heat is transferred in the fluids, that is gases and liquids. And today we are going to talk about the radiation. It's a beautiful concept, right? Radiation, like if the heat is transferred without any direct contact, or that is called as a radiation. And this heat transfer by means of electromagnetic waves. Okay, so for example, if you see the picture, okay, so we are warming up the heat, no, so warming up the hand by means of fire that is far away from us. So we are not directly contact with that wood fire, but still we are feeling that heat, right? So this is a radiation. Okay, and also it is a natural application, like we are getting a sun's heat energy. So sun is far away from our earth, still we are getting that sun's heat energy by through means of electromagnetic waves. So that is called a radiation. So radiation is the fundamental heat transfer mechanism that plays crucial role in various natural and industrial process. So here we are going to explore the radiation heat transfer, including electromagnetic spectrum, black body radiation, emissivity, and solar radiation. So welcome to this video. So we are going to talk about this electromagnetic spectrum and thermal radiation. Electromagnetic spectrum encompasses all forms of electromagnetic radiation ranging from radio waves to gamma rays. So the thermal radiation falls within the infrared region of the spectrum, and it is emitted by all objects with a temperature uh, above absolute zero. Okay, and thermal radiation, like it is characterized by its wavelength and intensity. The wavelength of emitted radiation depends on the temperature of the object. Higher temperature results in shorter wavelength and increased intensity. So that's why we are getting the we can able to sense the sun's heat energy far away from here. So its intensity is high. It's have a shorter wavelength, but intensity is high. That is why we are feeling that heat. Then black body radiation. So black body is an idealized object so that absorbs all incident radiation and emits radiation at a maximum rate for a given temperature. And black body doesn't mean that it is in black color, like it generally talks about the object. If the object absorbs all incident radiation and emits at a maximum rate, emits radiation at a maximum rate, it will be called as a black body. Okay, so its emitted radiation is described by Planck's law, which relates the spectral radiance to wavelength and temperature. And again, the emissivity is like a property. Okay, so it is a ratio of the radiant energy emitted by a real surface to that of emitted by a black body at the same temperature. So black body will be black body will be taken into consideration, that is like a reference material. And it will be like ratio of, we are having a different material that will be compared with the black body. Okay, so generally emissivity values ranges from 0 to 1, with 1 representing a perfect black body and 0 representing perfect reflector, right? And view factors. So view factors are geometric quantities that represent the fraction of radiation leaving one surface that strikes another surface. So they depend on the shape and orientation of the surfaces, and they are crucial for analyzing radiation heat transfer. A network analysis is a technique used to solve for net radiation heat transfer between multiple surfaces. It involves treating the surfaces as nodes in a network with resistance representing the radiative exchange between them. So, if you talk about the solar radiation, so solar radiation is a form of renewable energy that can be harnessed to generate electricity or provide heat. So solar panels convert solar energy into electricity while solar thermal systems capture solar energy for heating purposes. So we are using solar heater will be there, solar panels will be there. It will be like capturing that radiation and converted into another form of energy. Like applications like solar radiation has numerous application, as I said, that is for if we want to generate electricity, we can go for solar panels. If we want to generate heat energy, we can go for solar heater. Okay. And like future potentials, the use of solar radiation is expected to grow significantly in the future as technology advances and the need for renewable energy sources increases. So it has a potential to play a major role in addressing the global energy challenges as well, because this energy can be harnessed effectively. So that is why we are now concentrating more on renewable energy sources, and solar is one of them. Okay, that the basic concept behind that harnessing the energy from solar is because of radiation. And that's it for today. And if you have any questions, please uh, post your questions in the comment section. This is Vignesh signing off. Thank you so much.